What does the general workflow for Semaphore Classification Server look like? We have four general stages beginning with the ingest of unstructured content. This starts by receiving unstructured content such as PDFs, Word files, HTML, emails, or raw text from client applications. Content can be submitted through APIs, command line tools, batch jobs, or integrations like SharePoint and MarkLogic. Once received, CLS prepares and normalizes text, captures document metadata, and readies content for analysis. It then applies Semaphore language services to perform language-aware processing, such as tokenization and linguistic normalization, with support for multiple languages. CLS classifies the content using deterministic rule bases generated from semantic models managed in Semaphore. This means that classification is rule-driven and not probabilistic. Results do not change randomly. These rules determine what the document is about and assign confidence scores to relevant concepts. During classification, CLS can also identify entities and extract structured facts. Here's an example of a rule to detect a space mission. It starts with the if test, and if the result returns as true, then the rule assigns a class and base score. Finally, CLS assembles the results into a structured XML or JSON response and returns the enriched metadata to downstream systems. CLS remains stateless, focusing only on semantic processing and delivery of results. Here's an example of a text input and processed using a space mission classification rules. The example output is shown here and provides classification results based on a space mission rule. The example is in an XML response, but a JSON response can also be generated. Using this diagram, let's examine how the classification server works with a rule base. We start on the left with authoring. Using Semaphore Studio, authors create a semantic model that defines concepts, classes, and the linguistic rules used for classification. These rules can be tested locally using the document analyzer, allowing authors to validate behavior before anything is deployed. Once the model is ready, it moves into the build phase. Here, the authored rules are published and compiled into a compiled rule-based file. This step converts human-readable rules into an optimized runtime format that the classification server can execute efficiently. Next is deployment. The compiled rule-base is copied into a designated rule-base directory on the server. A configuration file called config.xml, tells the classification server where these rule bases are located. At this stage, nothing is executed yet as the system is simply being prepared for runtime. When the classification server starts or is restarted, it reads the configuration, locates the rule-based directory, and loads the compiled rule bases into memory. From this point on, the server is ready to process classification requests. Now we move into runtime classification. A client application sends an XML request over TCP containing the document text to be classified. This request is received by the classification server and passed into the rule engine. Inside the rule engine, classification happens in several steps. First, linguistic patterns are applied to detect terms, phrases, and entities in the text. Next, the system performs scoring and threshold evaluation, calculating how strongly the document matches different concepts and classes. Finally, class and concept resolution determines the final classification results, resolving hierarchies and conflicts if needed. Once processing is complete, the XML response generator creates a structured response. This response includes the matched concepts, matched classes, and their associated scores. The XML response is then returned to the client, completing the classification request. In summary, rules are authored and tested in Semaphore Studio, compiled into rule bases, deployed to the server, loaded at startup, and repeatedly used at runtime to classify documents and return structured results. For additional resources, check the video below.